Hello, everybody, and welcome to the third part of our lecture that is covered dewatering systems. In this part, we will discuss the permanent dewatering systems. First, what do we mean by permanent dewatering systems? Those systems or techniques are designed to continuously manage groundwater level over the long term. That means um, as soon as the structure exists, the dewatering system also exists. That's why they remain in place for the life of the structure. Dewatering can be defined, as we said before, as the process of draining rainwater or groundwater from an excavated area, and its aim is to provide a safe and stable subgrade for excavations. What are the advantages of the permanent dewatering system over the temporary systems? First, they ensure a long-term groundwater control. They are designed for continuous operation to manage groundwater levels over the extended life of the project. They can provide consistent groundwater management. That's why they ensure long-term stability and reliability. Such dewatering systems are suitable for large-scale infrastructure projects such as tunnels, basements, and subways. And they are able to reduce the hydrostatic pressure on the structure, thus preventing uplift or buoyancy. As we know, when we remove the water from a certain soil, and we are doing this in a continuous manner here, thus the soil strength and the bearing capacity will be improved. But what are the disadvantages or limitations of such systems? First, the high initial and maintenance costs that includes the infrastructure of the system, the power supply, and the regular servicing. Such systems are usually complex to be installed. They require detailed planning, design, and execution. They have huge environmental impacts because of their continuous operations. And they have a very limited flexibility. Why? Because once those systems are installed, they are not easily adjustable or removable. Permanent dewatering systems are then designed for specific conditions and may not be adaptable to changing project requirements. What are the types of permanent dewatering systems? In this lecture, I'm going to cover some types of dewatering systems that are the most widely used. Of course, there are others. For each type, you will cover the components, the technical advantages, the applications, and limitations. Let's start with the cut-off wall that is formed of the wall material that can be concrete, steel, or sheet pipe. That is designed to block the flow of groundwater. The second component is the trench of the excavation, which is dug around or within the excavation site in order to install the cut-off wall. And finally, we have the sealing method, which is done using grout or any other impermeable material in order to ensure a watertight barrier. Using cut-off walls has several advantages, including the permanent groundwater control throughout the life of the project, protection against contaminants. They need minimal maintenance and they are versatile. This diagram shows an example of a cut-off wall, where we can apply cut-off walls in basements and substructure constructions such as ground parking structures. It can be used for environmental containment to prevent spread of pollutants, for waterfront structures such as retaining walls, quay walls, and dams, and it can be used also for land reclamation to protect or prevent seawater intrusion and control groundwater levels in certain lands. What are the limitations or disadvantages? The high initial cost, the complex installation, it's not suitable for any depth, only for limited depth, and when using cut-off walls as the watering system, please keep in mind that there's a potential for ground movement, such as settlement, mainly if we are using the system in soft soils. The second type is the grout curtains that are formed of the grout injection points. They are a series of placed boreholes along the perimeter of the required area. The grout material, which can be cement, can be chemical grout, or any other type. The grout pumps that are high pressure pumps. And the monitoring equipment, which is very important in order to monitor that the grout is flowing as required, the pressure and the coverage during the injection process. This type of dewatering system ensures effective groundwater barrier. It has versatile application, customizable solutions, and leads to minimal service disruption. And this diagram shows us some examples of grout curtains, where we can apply grout curtains in projects such as dams and reservoirs, in underground structures such as tunnels, basements, for environmental containment, and also for slope stabilization. As other permanent dewatering systems, they have high installation costs. They are not easy to be installed and executed. They have limited longevity, and this is very important to remember. That's why their quality may degrade over time, and thus their efficiency may decrease. And they may have potential environmental impact, because the injection of a grout can change the nature flow of the groundwater, which have many environmental consequences which should be carefully managed. The other type of permanent watering systems is the groundwater lowering, which is formed of large diameter pumping wells that are installed around the site, and they are equipped with submersible pumps. The second component is the monitoring wells, which are additional wells that are used to monitor the groundwater levels. The control systems, which are automated systems that regulate the operation of the pumps based on real-time groundwater level data. And the discharge piping, which is a network of pipes that transports the extracted groundwater to designated discharge. Why it is good to use this type of dewatering system? Because it plays as a permanent solution. It provides a long-term and reliable method for controlling groundwater levels, mainly if the construction area includes high water tables. They can be applied to a wide range of projects, and they enhance stability by lowering the groundwater level. Thus, they reduce the hydrostatic pressure, they improve the stability of the excavations and the underground structures. They can control the water table by offering precise control over it, preventing the water ingress and associated risks during construction. And this is an example of how groundwater lowering goes on in construction projects, where we can apply such systems in underground infrastructures, such as tunnels, subways, basements, for waterproofing structures in order to maintain dry conditions, for slope and embankment stabilization, for mining operations. As previous systems, some of these disadvantages of the system is the high operational cost, the environmental impact, the complex installation, and the subsidence risks. Now we can go for another type, which is the drainage layers. Drainage layers are widely used systems. They are formed of permeable material that can consist of gravel, crushed stones, or any granular material that allow water to flow freely through the layer. They formed of the geotextile fabric, which is the most important component of such systems. In the upcoming lectures, I will be discussing the geotextiles in details because they are a very important topic in geotechnical engineering. Third, the component is the collection pipes, and finally the discharge system. Drainage layers work as an effective water management system. They need low maintenance, and they have versatile application, and they can help in soil stabilization. And in this figure, you can clearly see how this drainage layers are installed. This is the geotextile drainage, and here's the water, where the water goes through the cracks, and then it reaches the geotextile layer where it goes down, and then we have a relatively dry zone below the geotextile. The last type of permanent dewatering systems is the pumped wells that are formed of pumped wells, large diameter wells, of submersible pumps, of entering wells, and discharge piping. They have a high efficiency. They are able to remove large volumes of groundwater quickly and effectively. They can work on deep groundwater control. They are adaptable to various soil types and hydrogeological conditions, and they can provide stable and consistent groundwater control. Now, this diagram shows how these pumped wells are installed in a certain system. Pump wells are very useful for deep excavations, or as I said before, for infrastructure projects, for mining operations, and long-term dewatering. However, they have some disadvantages, such as the high installation and operation costs, the power dependency, and the high environmental impact. And there is a potential for subsidence, which leads to, because of the dewatering, may lead to ground subsidence, but particularly for or incompressible soils, posing a risk to nearby structures. So those are the permanent dewatering techniques that are covered in this lecture. Thank you so much, and see you in the last part of this series of lectures, where we will discuss the design considerations for dewatering systems, and we will highlight some software that are used to design dewatering systems in geotechnical and construction projects. Thank you so much.